This paper explores what we think is underlying the underlying mechanism for how white matter hyperintensity disrupts brain function. So white matter hyperintensities are just what you see on the brain. I mean, T2 or FLAIR scans. But we can use other MRI techniques, such as diffusion methods, to detect white matter microstructural damage. So what we did in this paper was that we measured fractional anisotropy and the mean diffusivity using tract-based spatial statistics from diffusion-tensor imaging. And we related this to cognitive function, as well as to semi-quantitative measures of cerebrovascular disease, such as white matter volume, intracranial disease, and counts of lacunar infarcts. Now, all these markers were associated with worse performance in cognitive function, especially the domains of executive function, attention, language, visual and visual memory, verbal and visual memory. And we also found that these markers of cerebrovascular disease were associated with the white matter microstructural damage as detected by FA and MD. We used a statistical method called path analysis, showing that these associations were mediated by white matter disruption in the commissural fibers, especially for verbal memory as well as executive function, whereas impairment in attention, visual memory, and language was mediated through projection fibers. So I think that this study is important because it shows how different cognitive domains are affected by microstructural changes in different pathways, and these are caused by cerebrovascular disease.